This video is for AQA Business Studies, Unit 2 and Decision Making. And it's looking at how to make decisions via a decision tree. So what a decision tree is simply a tool that's used to support decision making. So what it'll do is it'll map out or it'll draw out different decisions that could be made and the possible consequences or the event outcomes that could come from those decisions. So how we're going to do this is I'm creating a scenario for you. So if you're a student and you're coming to the end of your A-levels, obviously you've got a couple of decisions that you need to make. So within this scenario, you've got two decisions. You've got the decision of university or you've got the decision of an apprenticeship. Obviously there is the alternative, which is actually to do nothing, but within this scenario I'm making that impossible. So what we're going to do, within most exam questions you'll be given data based on the possible decisions. And you'll have to create a decision tree from that. So if we think about step one to start off with. Step one, from a decision, and the decision is drawn as a square, as we can see here. Okay? So the square, and from the square it has different lines which head out to the possible options from this decision. So the decision is that you're leaving sixth form and you're going to be doing something after education. It could be university, it could be apprenticeship, or it could be to do nothing. So they're the three options. So as I put here, these lines represent all the options you have before you. So within this, the decisions are represented by a square and the three options come from you via the lines. And the decision is that you're leaving Dubai English Speaking College, which is the school that I'm working at. Usually, but not always, each option will have a range of possible answers, and these are shown from a decision circle. So uncertain events and no control over what happens. So this is step two. So step two, you've got these circles. So there are two possible outcomes from each decision. In this scenario, I've said your parents and guardians will not let you do nothing. So there's no decision or there's no outcome for this one here for doing nothing. Okay, but you've got outcome here, and the outcomes are two different outcomes. You get better pay, you get worse pay. You get better pay or you get worse pay. Okay, so there are two possible outcomes from each decision, and they can depend on a range of factors. Now we're not necessarily predicting what these factors will be. We are just simply speculating that from this decision of either going to university or doing an apprenticeship, there are two outcomes: better pay or worse pay. Step three, you must then calculate the chance of each of these possible outcomes from occurring, and these are shown as a percentage. And again, the percentages will be given to you. So all this data will be given to you in the case study. You might have to draw the decision tree, but you will be given the data. So within this scenario, in terms of, so I've put in the extract from the previous example, someone has calculated the chance of each of these three outcomes occurring. So this was from the data. So we can see better pay, 72% for university, worse pay, 30% for university. Better pay for apprenticeship is 60%, worse pay is 40%. Now for stage four, again, this was in the table, this was data that was given to you. There will be a financial result of each option from this decision. So for example, if you decide to go for university and you get the better pay, then you'll get £250,000. If you get worse pay, it'll be £50,000. For the apprenticeship, better pay, £150,000, and for worse pay, it'll be £75,000. So someone's estimated the amount gained depending on certain factors. So for example, at university, if you get better pay, it might be because you did better at university. Or for worse pay, maybe you didn't get the grades needed. For apprenticeship, it could be the same. Or it could be one of the apprenticeships had better business contacts than the other, and that's why you're getting better pay. So now for step five, there's some calculations that come in. So we now need to calculate the expected value for each outcome, and this is done by multiplying the value of the outcome by the chance of the outcome happening. So for example, you do 250,000 times by 70%, and that would get you, so you can do this in your calculator now, and that would get you £175,000. 50,000 times by 30%, and that would get you £15,000. As I've put here, this is only theoretical. Okay, we will not get £195. This is similar to the work that you will have done in GCSE mathematics. Okay. Now, what I want you to do is I want you to go back to step 4 and I want you to have a look at the apprenticeship. And what I want you to do is I want you to calculate the exact same method for the apprenticeship. So I'm going to put it on pause and you can have a go at doing that now. So you should have got these calculations. 150,000 times 60% equals 90,000, and 75,000 times 40% equals 30,000. So you can see that the university has the better value at the moment, but what we need to do is we also need to look at the net gain value. So we'll go through that for step 6. So to work out the net gain value, you have to consider the cost of the option. So if you look back at the data in the initial table, it said that university was going to cost £60,000. So what you do is simply you do the 190,000, which is both of them combined, minus the 60,000, and you get a net gain value of 130,000. So you can do the same now for the apprenticeship. Now, if you remember, the cost of the apprenticeship was 10,000. So you can do that in 30 seconds. I'll pause it now for you. So what you should have got is, again, the 120,000 minus the 10,000, and that should get you a net gain value of 110,000. So again, the net gain value is higher for university. So within this decision tree, what you'd say within, if it was an exam answer, is that you'd be expected to go for the university choice. That would be the better option. So this is another question for you. Have a go at it. Pause the video, see what you get, and then we'll go through the answers. So you can pause it now and make sure that you calculate the highest expected value from option 2 and option 3, and then the highest net gain value as well. So we'll go through the answers of this at the end of the video. You should have done this now. So let's have a look at the next question and have a go at that as well. So this question, this was from Tutor to You. Have a go at actually drawing the decision tree, and let's see how you get on. So again, if you want to pause the video, and you can have a go at this, and then we'll go through the answers at the end of this video. Okay, you should have done that now. So the final question for you, and then we'll go through the answers, is the following. So again, 3 options: open a resort in Dubai, open a resort in Thailand, upgrade existing resorts in the Caribbean. So again, draw a decision tree. You can pause the video, have a go. So by the end of this video, you should have 3 decision trees, and then we can go through the answers. So this was the first answer. You can have a look at the calculations. So we did 0.4 times by 260,000 added on to 0.6 times by 100,000 for option 2. So that would get us 164,000 as a combined. For option 3, we had 70% chance at 740,000 and a 30% chance at 200,000. Again, that should get you 578,000. So the highest expected value is obviously option 3. However, again, we'd have to look at the cost to get the net gain value. So the net gain value would be 578,000 minus 400,000. And 260,000 minus 100,000. And what you should find is the highest net gain value is option 3 still. So if you were choosing between the two, you'd pick option 3. So for this second question, you had launch a loyalty card or you had cut prices. What you should have found is for launch a loyalty card, a £900,000, and for cutting prices, a potential return of 740,000. So now what you just need to do to get the obviously the net gain value is just minus 500,000 off 900,000. So obviously that would be £400,000, and then what you should do is your 740,000 minus 300,000, and that should get you 440,000. So actually, from looking at that, cutting prices would be the best option because of the net gain value. The net gain value is 40,000 higher. Okay, so for the final one, which is probably the most challenging one, this is what it should have looked like. I made a little mistake in the last box, so I've just rectified that, but you should have got, again, the net gain value for the new Dubai resort, 30, the net gain value for the new Thailand resort, 85, and the net gain value for upgrading to the Caribbean is 30, sorry, it's not 40, I accidentally put 30% rather than 20%. So, again, within this, the option you should really go for is the new Thailand resort. And in terms of the advantages of decision trees, it's just a way of, again, forecasting and putting more planning into your decisions, not just doing it on instinct, but having a scientific approach to it. And therefore, even though it's speculation, even though it's forecasted, even though we know it might not be the most reliable, at least you've actually thought about some of the outcomes, some of the consequences, some of the possibilities, and there's just more thought and planning that's gone into the decision. So you hope it'd make for a better decision.